Hello everyone, welcome to Far East channel. And what I wanna do today. So right now around 5 p.m. and I want to go to Taman Jaya to jogging and workout. So let's see my outfit for today. I'm wearing sports shoes, as you can see. So, see you there. Let's go. Hello. So, I just arrived here at Taman Jaya. So this is the environment. You can see some runner are training, some are workouts, and I wanna do my jogging first, and I'll see you. Okay, so 4 km done. And this is my last look. Okay, fighting Faiz, you can do it. By the way, the weather for today quite nice, not so hot.
A few moments later.
Okay, so I've done my 5 km. Whew, quite nice. Okay, so hello everyone, and today we are diving into something every athlete, coach or fitness student should understand: the science of how muscle move. Ever wonder what's really happening when you flex your arm or kick a ball? It's all thanks to something called the sliding filament theory. Let's break it down step by step. Whew. Okay. Before you get into the sliding part, let's zoom into what the muscle is actually made of. Inside your skeletal muscles, you will find long cells called muscle fibers. Within those fibers are even smaller threads called myofibrils, and inside those are sarcomes, the basic contractile units of muscle. Think of sarcomere like little engines, like up in a row, repeating again and again. So, actin, thin filament, and myosin, thick filament with heads that do the pulling. These filament don't shorten, they slide each past each other. So, which shorten the whole sarcomere and makes the muscle contract. That's why it's called the sliding filament theory. So, how does the sliding starts? Okay, let me explain. First, your brain sends an electrical signal to your motor neurons to muscle, and these signals reach the sarcolemma, which is the outer membrane of the muscle fibers, and the impulse travels down tune called the T-tubulus and reach the sarcoplasmic reticulum. This is where calcium ions are stored. When the impulse hits the SR, calcium ions are released into the sarcoplasm, the muscle's internal fluid, and that's the green light for contraction to begin. Okay, wait for me. Wow, cat. Wait, have cat. Okay, I will continue. So, for the unlocking the binding sites, the calcium ions then bind to a protein called troponin, which is attached to another protein called trypomyosin. This combo normally blocks the binding sites on actin. When calcium binds to troponin, it changes shape, moving trypomyosin out of the way and exposing the binding sites on actin. Now, the myosin heads can attach. This is called a cross bridge. Okay, here's where the action happens. Each myosin head use energy from ATP to tear forward and pull on the actin filament. This movement is called a power stroke. After pulling, myosin release, recess and grabs on again like a rower pulling oars through water. As this continues, the actin filament slide inward, the sarcomere shorten and the muscle contract. All of this require energy, which is ATP, an enzyme called ATPase, and even glucose and oxygen. That's why we need fuel from food. So, what happens when we stop the signal? So the calcium ions are pumped back into the sarcoplasmic reticulum by an active transport system that also use ATP. Without calcium, troponin and tropomyosin go back to their blocking position. The myosin can bind to actin and the muscles relax. It's like a reset button being pressed. The muscle fibers return to their original length and the contraction ends. Oh, sorry. My friends are here, so I just keep in touch with him.
Wait a minute! Who are you?
So, what we learned today is pretty cool, right? Muscles are like teeny machine inside us, running 24/7 to keep us moving. And if you enjoy this breakdown of the sliding filament theory, hit that like button, drop a comment, and if you get question, and don't forget to subscribe for more bite-sized science made simple. See you in the next video. Bye.